Welcome to the GCSE Maths Advantage. I'm Dr. James Carter, and every episode I'm going to break down one topic, show you where the marks are, and give you a quick win you can use in your next exam. Whether you're targeting a grade 7 or pushing for a 9, let's get into it.
Quick fact to start. Last year, a single Surds question lost more marks than almost any other on the AQA higher paper. Students wrote down the right idea, but lost marks through messy arrangement and a missed rationalisation step. If that sounds familiar, stay with me. This episode turns that question into a routine you can do under time pressure.
No jargon for the first 30 seconds. A surd is just a root, like square root 2. Indices are the small powers you see, like squared or cubed. And yes, roots are powers too. Treating them as the same idea is the trick that saves time and marks.
Right, the concept. First, notation and one simple translation. Wherever you see a root, you can write it as a fractional index. Square root of x equals x to the power 1/2, written x to the power 1/2. Cube root of x is x to the power 1/3. That single translation unlocks the index rules you already know.
So why does that help? Because the rules for multiplying and dividing powers work the same with fractional indices. For example, x to the a times x to the b equals x to the a plus b. If a is a half and b is 3.5, you add to get x squared. That means square root of x times x to the 3.5 equals x squared. It is the same algebra, just with fractions.
Negative indices. X to the n sub n means 1 over x to the n sub n. So x to the minus 1 over 2 is 1 over the square root of x. Keep that mental translation and you avoid sign and placement mistakes. Say it to yourself. Negative index, reciprocal.
Let's do a short worked simplification together. Simplify square root of 72 divided by square root of 2. First, write both as indices, 72 to the power of a half over 2 to the power of a half. Combine using quotient rule. 72 over 2 to the power of a half equals 36 to the power of a half, which is 6. Why that step works. The rule a to the power of a half over b to the power of a half equals a over b to the power of a half, because fractional powers distribute over division. Quick and neat, no messy factor hunting.
But sometimes you need to simplify by factorising too. If instead you had square root of 18, you could write 18 as 9 times 2. So square root of 18 becomes square root of 9 times square root of 2, which is 3 square root of 2. Translating to indices, 18 to the power of a half equals 9 to the power of a half times 2 to the power of a half equals 3 times 2 to the power of a half. Both views say the same thing. Practice both to be fluent.
Now, the examiner's headspace, how marks are awarded. For a typical 3-mark question on surds and indices, you'll see M marks for method and A marks for accuracy. For instance, M1 for rewriting roots as fractional powers or factorising the third, M1 for correct manipulation using index laws, and A1 for the final simplified value. If you write down the first correct step, you bank that M1, even if you can't finish.
So layout matters. Top line, state your translation or factorisation, e.g. square root of 50 equals 5 square root of 2, or write 50 to the power of a half. Next line, perform the index law step. Final line, give the simplified result. If you must stop early, the examiner sees your method and will award method marks. Write it down, don't just think it.
Quick win time, the conjugate trick for rationalising denominators. If you have a denominator like square root of 3 plus 1, multiply top and bottom by the conjugate square root of 3 minus 1. That turns the bottom into square root of 3 squared minus 1 squared, so 3 minus 1 equals 2. Suddenly you have a clean rational denominator. This is the single step that frequently decides full marks on surd questions.
10-second check you can do after rationalising. Square back or substitute. Take your simplified answer, square any third pieces, and check the arithmetic roughly against the original expression using a quick decimal approximation.
If the numbers are wildly different, you dropped a sign or a factor. That one small check catches most careless slips.
Worked example at exam pace. Question. Simplify 5 divided by the square root of 3 minus the square root of 2. Step 1. Multiply numerator and denominator by the conjugate, the square root of 3 plus the square root of 2. I'll write each line as you should on the paper, so the examiner sees your method.
Line 1. 5 multiplied by square root of 3 plus square root of 2 over square root of 3 minus square root of 2 multiplied by square root of 3 plus square root of 2. That's the M1 for attempting the conjugate. Line 2. Denominator becomes 3 minus 2 equals 1. Numerator expands to 5 square root of 3 plus 5 square root of 2. Final answer, 5 square root of 3 plus 5 square root of 2. That's A1 for the simplified exact form. If you stopped after line 1, you still show the correct method and gain that M mark.
Common micro mistakes to watch for. Dropping a negative when using negative indices, forgetting to apply the fractional power rule, for example treating x to the half times x to the third as x to the 2/5. That's wrong, you must add indices. And expanding conjugates incorrectly. Another frequent slip is leaving a surd in the denominator when the question asks for a rationalised answer.
Fast checks under time pressure. 1. Read the question twice. Are you asked to rationalise? 2. Translate roots to fractional indices in your head to spot manipulations quickly. 3. Substitute decimals. If your simplified exact answer is roughly equal to the decimal of the original, you probably didn't drop a sign. These 3 small habits save marks.
2 final quick reminders. Practice the conjugate multiplication until it feels like a routine, and always show the first algebraic step. That is the examiner-friendly action that often wins you a method mark, even if the arithmetic gets messy.
That's your quick win for today. If this helped, share it with a friend who's revising. You'll find more worked solutions and revision resources at jcacademyonline.co.uk and a short practice pack on Gumroad that drills these exact routines. Until next time, trust the process and nail that exam. Stay curious.